Let's take a look at how the CPU uses the fetch, decode, execute cycle to perform actions. What we're going to take a look at is a really simplified version of the fetch, decode, execute cycle. If you go on to study GCSE Computer Science in Year 10, you'll learn a lot more about how this cycle works and how the different components in the CPU work. The first part of the cycle then is to fetch. In this case, we're going to fetch a number from our memory. Now, the memory is divided up into different sections. They're called partitions. And each partition has an address 001, 002, 003, 004, etc. And then in the other part of the partition, there is either some data, the number 16, 32, and 7, or an instruction to add, subtract, divide, or multiply. Our program counter keeps a track of how many instructions have been carried out, and it's always one step ahead of the current instruction that it's doing. So it doesn't start counting at 1, it's starting to count at 2. The memory address register is updated with the first memory address that the CPU needs to go and fetch some data from. That's 001. The data is fetched along the buses, and the number 16, the data that's stored there, is then put into the memory data register. Now the CPU can start its second fetch, decode, execute cycle. The program counter has increased by 1, so we're up to 003, and this time we're going to grab some data from memory address 4, so the memory address register is updated. The CPU fetches the data from memory address 4. It looks at the data that it's fetched to understand it and realizes that it's a plus sign that it's fetched. That's an instruction to add. So that instruction gets stored into the current instruction register. The data value 16 that was fetched from the previous cycle is moved from the memory data register and stored into the accumulator. Now the CPU can start its third fetch, decode, execute cycle. The program counter is increased again by 1 to 004. Now we're going to fetch some data from memory address 002, so the memory address register is updated. The CPU fetches the data, the number 32, from that memory address and stores it in the memory data register. It also knows that it's got to add two numbers together because in the current instruction register it's got the plus command in there. The number that it's just fetched from memory, 32, is copied across to the arithmetic logic unit along with the previous number 16 that was stored in the accumulator, and the arithmetic logic unit adds both numbers together and comes to the result 48. The number 48 is then stored in the accumulator, ready to be used in the next cycle.